morning, class. My name is Livingston Ozana, and today in mathematics class, I'll be talking on the topic permutation and combination. Firstly, what is permutation? Permutation is the orderly arrangement of things or objects. It is generally represented as this is the permutation symbol. Now, I said that permutation is the arrangement. So if I was to arrange five structures, taking three at a time, it would be five permutation three. Further represented as 5 factorial all over 5 minus 3 factorial. Generally, permutation is represented as n PR equals to n factorial over n minus r factorial. Now, I said I was talking about permutation and combination. What is combination? Combination is the selection of things or objects. It is applied in our library and in our school. Generally represented as with the symbol C. So if I was to select three structures out of five, it will be 5 combination 3. That is 5 factorial all over 5 minus 3 factorial 3 factorial. Generally represented, combination is n r equals to n factorial all over n minus r factorial r factorial. I'll be talking about the factorial, and I'm guessing you want to know what it is. The factorial is a symbol. This is the factorial. The factorial is a symbol that is attached to a combination or permutation equation, which makes that number, let's say 5, to multiply all numbers below it till 1. Let's use 5 factorial. 5 factorial here. If you were to find 5 factorial, we multiply 5 to 4 and 3 times 2 and stop at 1. There's no multiplication of 0. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120, and 120 times 1 is 120. So 5 factorial is equal to 120 ways. But today we'll be talking, I would like to take two questions on permutation and combination. Okay, this will be our first question for today. 9 combination x equals to 4 open bracket, 7 combination x minus 1 close bracket. This is the WAEC 2025 for that maths question 1. Let's start solving. Combination x equals to 4, 7 combination x minus 1. I said something about combination being the selection. I have not represented the combination equation. I'm going to do the same for both of them. I'm going to take them one by one. So 9 combination x will be 9 factorial all over 9 minus x factorial x factorial. 7 combination x minus 1 will be 7 factorial all over 7 minus x minus 1 factorial x minus 1 factorial. I'm going to substitute this and this into this equation. So 9 combination x equals to 4 bracket 7x combination x minus 1 close bracket to now be 9 factorial all over 9 minus x factorial x factorial equals to 4 open bracket 7 factorial all over 7 minus x minus 1 factorial x minus 1 factorial equals 0. I'm going to open the bracket now. So it will be 9 factorial over 9 minus x factorial x factorial equals to 4 times 7 factorial over 7 minus x minus 1 factorial x minus 1 factorial 9 factorial all over 9 minus x factorial x factorial to be 4 times 7 factorial all over. Let's open this bracket. 7 minus x plus 1 factorial x minus 1 factorial. Note that the factorial attached to a number can help make the number to multiply down till 1. So if I was to expand this 9, I can be able to eliminate this 7. Okay, 9 factorial is the same thing as 9 times 8 times 7 factorial. So I'm going to substitute this into this and use it to eliminate 7 factorial. So 9 times 8 times 7 factorial all over 9 minus x factorial would be equals to 4 times 7 factorial all over 7 minus x plus 1 factorial x minus 1 factorial. This and this will cancel themselves and go. 9 times 8 is equals to 72. 9 minus x factorial x factorial equals to 4 over 7 plus 1 is 8. 8 minus x factorial x minus 1 factorial. Understand that the factorial also attached to a question like this can also use it and will make it possible that I can use this to eliminate this. So let me show you. 9 minus x factorial is the same thing as 9 minus x, 8 minus x, 7 minus x, going down to 1 minus x. Substitute this into this place and use it to eliminate this. So 72 all over 9 minus x, 8 minus x factorial equals to 4 all over 8 minus x factorial x minus 1 factorial. This and this will cancel themselves and go away. 72 all over 9 minus x factorial all over 4 x minus 1 factorial. I said that the factorial attached to any figure or number makes it to go down to any other number. So x factorial is the same thing as x minus 1, x minus 2, see any x minus n factorial. So I'm going to put this the factorial possibly into this to eliminate this. 72 all over 9 minus x minus 1 factorial equals to 4 over x minus 1 factorial. This and this cancel themselves away. 72 over x 9 minus x equals to 4 over 1. They will cross multiply and we are going to get 4x 9 minus x equals to 72. 4x times 9 is 36x and 4x times minus x is minus 4x squared equals to 72. I'm going to put this in the quadratic equation form and that is 4x squared minus 36x plus 72 equals to 0. So you can see that All the numbers here are multiples of 4. So I'm going to divide 2 by 4. I have x squared minus 9x plus 18 equals to 0. I'm going to call this equation 1. So now, I'm going to solve this equation by the factorization method. Factorizing equation 1. Factorizing equation 1. The possible factors are minus 3 and minus 6. So I'm going to put this into this equation. So x squared minus 3x minus 6x plus 18 equals to 0. Looking for x. I'm going to group them. X squared minus 3x minus 6x plus 18 equals to 0. I'm going to bring out one factor that will make these two the same. So removing x from here to be x minus 3, and removing minus 6 from here to minus 6x minus 3. We're going to take only one from here, so it will be x minus 6 equals to x minus 3. X now is equals to x now will either be x equals to 6 or x equals to 3. So x is 6. There's our question 1. And we are done with the first question. Let's move to the second. So, a committee of 3 men and 4 women is formed from 5 men and 7 women. How many different committees can be formed if A particular man must be on the committee, B, 2 particular women must not be on the committee? This is the WAEC 2005 13B question. Now let's solve. Now, for the A particular man must be on the committee. Now, we have 5 men and we are to choose 3. I said something about combination being selection, the selection of things and objects. Here we are to select, we are to choose. So this is a combination question. We are to choose 3 men out of 5, and 1 is already selected because a particular man must be on the committee. 1 selected makes the remaining from these 3 men 2, remaining from these 5 men 4. So if 2 are remaining here and 4 men are remaining to choose 3 from, it will be 4 men to choose 2 from. Equals to 4 combination 2. This is for the men. They don't say anything about the women here, so there are no restrictions on the women. The women are going to be for the women. 7 women to choose 4. So to be 7 combination 4. To find the total possible ways, of creating a committee where a particular man must be on it will be 4 combination 2 times 7 combination 4. Now let's expand this to 4 combination 2 is equal to 4 factorial all over 4 minus 2 factorial 2 factorial. That is 4 times 3 times 2 times 1 all over 4 minus 2 is 2 factorial. That is 2 times 1 times 2 factorial. 2 times 1. 1 equals to 1, 2 equals to 2, 2 equals to 4 plus 2. So 2 times 3 divided by 1 is equals to 6. Now, 7 combination 4. That is 7 factorial over 7 minus 4 factorial 4 factorial. That is equal to 7 times 6 times 5 times 4 factorial. Oh, 7 minus 3 is 7 minus 4 is 3. That is 3 times 2 times 1 times 4 factorial. This and this will cancel themselves. 3 going to 6 is 2. 2 to 2 is 1. 7 times 5 is 35. 35 divided by 1 is equals to 35 ways. So the total possible ways, of having a committee where one particular man is must be on the committee is 6 times 35 ways, but that is equals to 210. That is the A part of the question, and we are done. Let's move to the B. Okay, now we are going to the B part of the question. This part of the question, it tells that two particular women must not be on the committee. 7 women to choose 4 from. So if we remove 2 women that must not be on the committee, that is 7 minus 2, and that is 5 women. 5 women are now present to choose 4 from. So we will choose 4 women. We have to choose 4 women from 5 women. That is 5 combination 4. The men are, they are okay, they don't have any restriction. Therefore, from the men we have to choose 3 men from 5 men, and that is equals to 5 combination 2. The total possible ways of forming a committee where 2 particular women are not and must not be on the committee is 5 combination 4 times 5 combination 3. Let's expand this. 5 combination 4 is equal to 5 factorial over 5 minus 4 factorial 4 factorial. 5 factorial over 1 factorial 4 factorial. That is equal to 5 times 4 factorial. 1 factorial is equal to 1. 1 times 4 factorial is 4 factorial. That is 4 factorial. This one is supposed to be 5. So 5 combination 4 is equal to 5. 5 combination 3 is equal to 5 factorial over 5 minus 3 factorial 3 factorial. That is 5 factorial over 2 factorial 3 factorial. It's only 5 times 4 times 3 times 2 factorial over 2 factorial times 3 times 2 times 1. So 2 factorial and 2 factorial equals 3 and 2 going to 4, that is 2. So 5 times 2 is equals to 10. Multiplying these two together, the total possible ways of having a committee where 2 particular women must not be on is 10 times 5 ways, and that is equals to 50 ways. Therefore, the total possible ways of having a committee where these 2 particular women are not on is 50 ways. Thanks for watching.